Hello everyone. In this video we are going to discuss about the construction features and working principle of a 4-stroke petrol engine. I am Shivshankar Srivatsa. This video would be definitely useful to any students of engineering, especially who study a subject called as elements of mechanical engineering. The students can be from any of the branch of engineering. So the basic objectives of this video is to recognize various parts of a 4-stroke petrol engine, and once you complete watching the entire video, you will be able to understand the working principle of a 4-stroke petrol engine. So we are going to look at what are the various parts of a 4-stroke petrol engine, what necessarily are these 4 strokes that we are talking about, and what are the different processes involved in the working of this 4-stroke petrol engine, and how do we represent it by a thermodynamic cycle which shows the variation of pressure and volume. So first we will have a look at the various parts of this 4-stroke petrol engine. So what you see over here is an illustration of various parts of this engine. So basically it has a piston here at the center which is going to reciprocate inside a cylinder. So this will move to and fro inside a cylinder. So this reciprocating motion of piston needs to be converted into rotary motion. In order to run an automobile, we need rotary motion because the wheel has to run. So this reciprocating motion of piston is converted to rotary motion by use of a connecting rod and a crank. In order to control what gets into the cylinder, what goes out of the cylinder, we have 2 valves over here which control. The first one is called the inlet valve, which controls the input to the cylinder. The second one is called as the exhaust valve, which controls the gases going out of the cylinder. In order to initiate combustion, we have a spark plug in a petrol engine, which initiates a spark, ignites a spark to initiate combustion of fuel. Now when we say a 4-stroke petrol engine, we need to understand what these 4 strokes indicate. So in order to have an understanding of what a stroke is, this top portion of the cylinder is called as top dead center, TDC. And the lower portion of the cylinder can be called as bottom dead center, which is denoted as BDC. So when the piston moves from one end to the other end of the cylinder, say from top dead center to bottom dead center, that is called as one stroke of the piston. So in order to complete one working cycle, in the case of a 4-stroke engine, the piston has to perform 1, 2, 3 and 4 different strokes. So it moves 4 times from one end to the other end to complete one thermodynamic cycle. That is why this engine is referred to as a 4-stroke petrol engine. So these strokes can be basically identified as suction stroke. The second one is called as compression stroke. The third one is called expansion stroke. The fourth is called as the exhaust stroke. So I look into the detail of each of these strokes. What are the processes involved? The first stroke is called as the suction stroke, wherein in the first suction stroke, this inlet valve is open. At the beginning of the stroke, the piston is moving from top dead center to the bottom dead center, from top to bottom. So when the piston is moving from top to bottom, one end to the other end, the concept over here is similar to what we see in a syringe. When we move the piston in a syringe from one end to the other end, it draws fluid into the syringe. In a similar way, when piston moves from top dead center to bottom dead center, the air petrol mixture from the carburetor gets into the cylinder. So the basic fuel in case of a petrol engine is the air petrol mixture. So this fuel gets into the cylinder in the first stroke. So this stroke is represented by a PV diagram. So the pressure necessarily remains constant at atmospheric pressure or a constant pressure. So we can see the volume increasing during the suction stroke, which necessarily takes place at a constant pressure. The second stroke is called as the compression stroke. So during compression stroke, we have the fuel which is taken into the cylinder. Now the inlet valve is getting closed. The inlet valve closes. Now the piston is at the bottom dead center. As the crank rotates here, the piston moves from bottom dead center to the top dead center. Because the valves are closed here, the fuel inside the cylinder gets compressed in the cylinder. So as a result of compression, the air petrol mixture that is inside the cylinder would reach a very high value of pressure on compression, and at the same time it also will have a very high value of temperature, which necessarily would reach the ignition temperature of petrol. So this stroke is represented by the curve 2 to 3. Point 2 to 3 represents the compression stroke, wherein you can see that the volume is reducing, at the same time the pressure is increasing. The third stroke is called as the expansion stroke or the working stroke, wherein during this stroke, we have, at the end of the second stroke, we have the compressed air petrol mixture at a very high pressure and temperature. So at the beginning of this stroke, a spark is initiated by the spark plug. So the air petrol mixture, because of compression at high pressure, high temperature, it will have reached almost gaseous state. This is something like you have a gas and you are introducing a spark through a lighter. So the moment you have a lighter igniting the gas, it immediately catches fire. In a similar way, the air petrol mixture also gets burnt in the cylinder, because of which it is going to force the piston to move downward. So the air petrol mixture, the gases, hot gases that get generated inside the cylinder, they force the piston to move from top dead center to the bottom dead center. So this process is represented by two lines, one 3 to 4 and other is 4 to 5. 3 to 4 indicates sudden increase in the value of pressure due to the ignition of the fuel. Then the hot gases generated, because they are at very high pressure at P4, they force the piston to move downward, which makes the volume to increase and the pressure to gradually go down. So this process is represented by the curve 4 to 5. The final stroke is called as the exhaust stroke. So once the compression stroke is complete, we have the exhaust gases, burnt gases remaining inside the cylinder. So at the beginning of this stroke, the exhaust valve opens. So the moment the exhaust valve opens, the exhaust gases inside the cylinder suddenly go out of the cylinder, reducing the pressure. Then the remaining gases that are left out in the cylinder, they are moved out due to the movement of the piston. The piston will be moving from bottom dead center to the top dead center. So the exhaust gases that remain inside the cylinder, they go out of the cylinder. So this process is represented by two lines, 5 to 2 and 2 to 1. 5 to 2 indicates reduction in pressure, sudden reduction in pressure due to the opening of the exhaust valves. Then when the piston moves from bottom dead center to the top, the volume is getting reduced. So that represents process 2 to 1. So this is the final stroke. And then this cycle is repeated 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 2, 2 to 1. So it is repeated. So this cycle has all the 4 different strokes that we discussed about. So if you look at the cycle that we are talking about, it has 4 processes: the suction, compression, expansion and exhaust. So they are represented by different curves. So curve 1 to 2 over here represents the suction process. Then 2 to 3 represents the compression process. The expansion is represented by 2 lines, 3 to 4 and 4 to 5. Exhaust is represented by 2 lines, 5 to 2 and 2 back to 1. So the cycle 1, 2, 3, 4, 5 to 1 is what is called as theoretical Otto cycle. So all petrol engines work on the basis of theoretical Otto cycle. So in this session, what we have necessarily learned are what are the different parts involved in a 4-stroke petrol engine. Then what is the principle of working? Why do we call it as 4-stroke engine? What are the different processes involved? How exactly the pressure and volume change? And what is the cycle based on which the petrol engines work? I hope this will be useful for your studies. Thank you.